In this lecture, we're going to see how we can work with function templates with multiple parameters. So far, we've only been working with really one template parameter, which was t. But in this lecture, we're going to see that it is possible to have multiple template parameters. And here is a simple example. The way you do that, you use the syntax we see here. You say template, you put in your angle brackets, and then in your angle brackets, you put a comma separated list of template parameters. And these are going to be prefixed with the keyword type name here. So here you see we have two template parameters, t and p. And we can use this in any way we want in our function declaration. For example, here we have our function called problematic maximum, and it is going to take two template parameters. The first one is going to be of type t, the second one is going to be of type p. And the compiler is going to automatically deduce this from the parameters we try to call this function with. But before we really see how we can call this function template, there is a problem. So what's going to be the return type of this function template if we do things like this? You notice I have left the return type empty on purpose because this is a problem. And now we have a few options, but most of them are going to be problematic. One way we can do this is to return one of these template parameters as the return type. And this is the syntax we could use to do this. But the problem is that now our return type depends on the order of the parameters in our function call. The return type is basically the second parameter here, and if our function, for example, is called with int and double, this is going to return double. If we call it with double and int, it is going to return int. This is clearly bad design, and we don't want something like this. If you switch and return t, this is really not going to solve the problem. It's just going to change the order of the parameters. We need a better solution. One way we can solve this is to set up a separate template parameter for the return type. And now we can set up a function like this. We can say return type as a template parameter, and then we're going to put in our other template parameters. When we call the function like this, we set it up to have this return type here. It's going to have our parameters n, and the compiler is going to deduce all these things. It's going to deduce t and p based on what we call our maximum function with. It's going to deduce the return type based on the type of this expression we are doing in the function body. This is going to work all fine. Okay, with this setup here, we can try and call our maximum function. And here is a simple example. We are calling the maximum function here. We are specifying our explicit template arguments. We have to do this because we have to help the compiler out in deducing the return type. The compiler can do its best and deduce the parameters, but it can never deduce the return type. So we need to really help it out here. So we're going to specify our return type as int, and t and p are going to be automatically deduced to be char and long here. In the second call, the return type is also going to be int, and we're going to specify the second parameter, which is probably t, in our function declaration. And the last parameter is going to be deduced from the function call we are doing here. So this is all fine. And the third call here is basically going to do the same. We have the return type. We didn't specify the other template arguments, and they are going to be deduced from the function call here. So t is going to be deduced to be of character type, and p is going to be deduced to be of long type because this is a long literal. This is all going to work fine. What is not going to work is the call like this. We are already passing in two template arguments, t and p, but the return type can't be deduced by the compiler. You notice we are not helping our compiler out with a pair of angle brackets in front of the function call like we did before. And the compiler is basically on its own in figuring out the return type of this function, and it is going to fail because the compiler can never deduce the return type. So this is going to give us a compiler error. And don't worry if any of this is not making any sense for now. In a minute, we're going to head over to Visual Studio Code and really make this super clear. I am just going to give you first-hand knowledge on these things before we use them in Visual Studio Code. So what we just looked at are a few examples of how we can call this function template we have here. But before we get there, I want you to see a few combinations of how you can order your template parameters and how that affects how you can call your functions with parameters. Here we have what we have seen before. The return type is coming in the first position here. And we can either call our function by specifying all the template arguments int char long. So the return type is going to be deduced to be int here. The second parameter, which is t, is going to be deduced to be c here, which is of char type. And the third parameter, which is p, is going to be deduced to be long, as you see here. Here we are assuming our function template is going to take our function templates in this order. TA, for example, and PB. Okay, so T is going to be the first parameter and P is going to be the second parameter. And we're going to deduce things like we see here. Max2 is going to specify two explicit template arguments. The first one is going to be int, which is going to be our return type. The second one is going to be char, which is basically going to be t here. And the third argument is not specified here. So the compiler is going to deduce this from what we call our function with here. So p is going to be deduced to be long because the compiler can deduce this from the function call we make here. The third call here is going to only specify one explicit template argument, and this is going to be our return type. And all the others are going to be deduced from the function call we make. T is going to be deduced to be of char type, and P is going to be deduced to be of long type, as you see here. The fourth call is not going to compile because now the compiler can't deduce the return type. We're not giving it any more additional help, so we're going to get a compiler error. The second series of examples here is going to put the return type in the second position, and this is going to change how we call our function template here. The first example here is going to specify all the template arguments, so this is going to work. The second one is going to only specify two. Remember, the return type is in the second position here, so this is going to work because the third one is going to be deduced from the call we make in our function call here. But starting from the third call here, we're going to get a compiler error because we're not specifying the return type. Remember, again, the return type is now coming in second position. So what we have in the first position here is really t. It's not the return type. So return type can't be deduced. We're going to get a compiler error. The third series of examples we have here is even more restrictive in how we can call our function template here. The first one here is going to work because the return type is in here. We have a template argument for the return type, which is going to be int in this case, but all the remaining function calls are not going to work because we don't have a template argument for the return type, and the compiler can't deduce our return type, and we're going to get a compiler error. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is function templates with multiple parameters. We're going to grab our template files pretty quick, and we're going to put them in place 24/7 here. Let's do that, and we're going to open this little guy in Visual Studio Code by dragging and dropping on top of Visual Studio Code here. This is going to open our folder. We're going to open the main CPP file, close the left pane here, and we're going to clean this up a little bit, and we're going to set up our function template, which takes multiple parameters. The syntax is what we have seen before. So we're going to say template and a type name T and a type name P. These are going to be our templates. And then from this, we need to specify the signature of our function. But we have a problem. We can specify the name of the function and say maximum, for example, and pass in our template parameters T and say A and P, B, and go in the body of the function and put in our return expression. For example, we can say return A greater than B, and if A is greater than B, we're going to return A. If it's not greater than B, we're going to return B. This should be our return expression. But we have a problem here. What's going to be our return type? So we are comparing A of type T and B of type P, but we don't know the return type. And if we try to compile our code like this, you see that we have a squiggly line. It's not going to work. Let's try and bring in our terminal and see the problems tab. Explicit type is missing, int assumed. And what this really means is that we don't have a return type. One might try to say, okay, we can return t, and this is going to be accepted as C++ syntax. It's going to be valid C++ syntax, but this is really bad design because the return type depends on the order of the parameters we pass in here. So for example, if we head over in the main function and say int a and put in a 5 and say double b and put in 6.7, why not? And say auto result equals maximum a and b, that's what we're going to pass in here. The first template argument is of type int now, so this function is going to return int. But if we change the order of things and say ba here, the type is going to be of type double because the double type is now coming in the first position, and we call our function in this order here. Hopefully you can see this. And let's try and print the size of the return type. You're going to see that it's going to be 8 on my computer here. So we can say size of result and say size of result here. And if we run this program as is now, b is coming in the first position. It is of double type. So t is going to be deduced to be of double type. That's the first parameter here. And a is going to be deduced of int type. And that's going to be the second parameter here. And we're going to return t. So we should return whichever type we have in the first position in our function call here. And that's going to be double. So we should expect to get an 8 if we print this out. If we run this application, let's build it. It's going to generate our template instance, which is going to be what we expect. And we're going to call that and return double type. That's what we're going to deduce with this auto keyword here. And if we print the size, we're going to get 8 printed out. Look at this, 8. But if we change the order of this function call and say a and b, now the first parameter is of int type. So t is going to be deduced to be int, and we're going to return int, and the template instance is going to return int, and we're going to deduce int here. And if we print the size of result, now it's going to be a 4 because an int is 4 bytes on my system here. Let's build again and really prove this. The build is good. We can clear and run Rooster. Now you see that the result is of type int because it has 4 bytes in memory. So by now you should really see that this is a problem, and our function here is not going to be reliable because the return type depends on the order the arguments are passed in when we call the function right here. So we need a better way to do this. One might try to say, okay, what if I return p here? It really is the same thing. Now the return type is going to be specified by the second parameter, and again it depends on the order of the arguments. This is not good design, and we need a better way to solve this problem. One way one might solve this is to specify a separate template parameter for the return type. So we're going to say that this is problematic. Hopefully you understand why. Return type depends on the order of the arguments, and this is bad. Okay, we don't want this. We need to do better. What we're going to do is specify our return type as a separate template parameter. We're going to say type name in here, and we're going to say return type. We can give our template parameters names, and let's say return type. I think this is going to do. You can really name this however we want. So in this case, I'm going to say return type because that's what we want to use this for. And now we can say return type. And we have really solved the problem we had here of not having a safer way or a good way to specify our return type. Now, the return type is going to be deduced from what we use here. Now, the return type is going to be deduced from the return statement here. This expression is going to be evaluated. We're going to grab its type and use that as the return type. Okay, now that we have this in place, let's try and look at the function here and try to analyze why it is not working. Because we have a squiggly line here. Visual Studio Code is not happy about what we have now, and it is saying no instance of function template maximum matches the argument list. Why is this? The problem is the compiler can't deduce the return type by itself. That's just how compilers work. They don't have enough information to know the return type by themselves based on the arguments that we pass inside. We have to help the compiler in deducing the return type. We can help the compiler by giving it explicit template arguments when we call our function. And we can do that by specifying a pair of angle brackets after our function name. This is where we specify our template arguments. And we're going to say the return type is going to be of double type. The first parameter, which is the second template parameter here, is going to be of double type. Why not? We can really use any type we want. Let's say double and double and double here. So the return type is going to be of double type. T, which is the second template parameter, is going to be of double type because that's what we have in the second position, and that's the first template argument in our function. And P, which is specified in the third position here, is going to be deduced to also be double. Now you see that we have normal squiggly lines. Visual Studio Code is happy. If we try to compile this with GCC, GCC is going to work. Now it has enough information to call our function template here. And if we print out the size of the result variable now, we're going to get 8. Because we have specified our return type to be of double type as we have here. Let's run this program. We're going to clear and run Rooster. You're going to see that it's going to be 8. And now we have the flexibility to change the return type however we want. If we want it to be int, it's always going to be int. It's not going to be depending on the order of the arguments that we pass to this function here. And this is really cool. So we can build again. The build is good, we can clear. And now if we run Rooster, size of result is going to be 4 because we specified our return type to be int here. This is really how these things work. And you can use this technique to get around the problem that we had seen on top here. Okay, this is really working and it is good. But one other thing I want you to be aware of is that you can specify the return type in other positions here. And we're going to see how this works. The further you move the return type, the less flexible it's going to get to call your function and let the compiler deduce things. What do I mean by that? Let's suppose we put our return type in the second position. Let's grab this guy here and say return type and say template type name. And we're going to take T and move that in the first position here. Why not? We can do this. So we remove the second comma here. And now the return type is going to be specified in the second position. Once we do things like this, we have a few options in how we call our maximum function here. The return type is specified second. Now it is specified and we are helping the compiler out in deducing the return type of our function here. It is going to be double in this case because the return type is specified in the second position as you see here. We can prove this by building and running. Okay, so the build is good. We can clear and run Rooster. The size of the return type is 8. We can prove that it is 8 here. And it is of double type. Now, what if we want to avoid some template arguments to make it easier to call this function here? Suppose we avoid to specify the third parameter here. The thing is, this call is going to work because the compiler knows the return type and it can deduce the other things through the function call we do here. So because we are calling our function with T and P, T is going to be the type of the A argument here, which is going to be int. And P is going to be the type of the second argument here, which is going to be double. So the compiler is going to deduce this without a problem, and it is going to compute our maximum, and it is going to return a type of double. So let's try and compile this and show you that it works. Okay, this is building fine. We can clear and run Rooster, and the size of the return type is 8. So the return type must be double. But let's take out the second template argument here and see what we get. Now we have a squiggly line because now the first template parameter is going to be used for T because this is the order we have our template parameters in. The first guy you specify in this angle bracket is going to be a placeholder for T here. So int is going to represent t here, and we have no way to help the compiler to deduce the return type, so we're going to get a compiler error. If we try to build this and ignore the squiggly line, we're going to get a compiler error, and it's going to say could not deduce template parameter return type, because this is the return type of our function, and the compiler can't really deduce this by itself. So if we have our template parameters specified in this order, the only way we can really call this function is if we have at least 2 template arguments specified. Let's put this guy back in, and you're going to see that now the build is going to be good. We can build with GCC, and you know the limitation of doing things this way. But this is not the only way. We can push things a little further and put the return type in the 3rd position. Let's copy our line here and put that here, and we're going to remove the comment here, and we're going to move our return type in the 3rd position. We're going to grab the other guy here, and we're going to put the p parameter 2nd. And now if we do things like this, you see we have the option to specify 3 parameters. This is going to work because the return type is specified in the 3rd position. This is going to compile and run. Let's compile and really show you this. But the moment we specify less than 3 arguments, we're going to get a compiler error because the return type comes in the 3rd position. Hopefully you can really see that pushing the template parameter for your return type further in the template parameter list is going to constrain the flexibility you have in omitting the template arguments when you call your function. I really hope this makes sense. So if you want much more flexibility, please put your return type in the 1st position. Let's comment out the 3rd line here and bring back the 1st here. The return type is going to be in the 1st position, and now this is going to work. If we do things this way, we have the option to specify all the parameters, or the arguments I should say. This is going to compile fine and dandy. Let's build. You're going to see that the build is good. We have the option to not specify the 3rd parameter because the return type is specified first. We have the option to not specify the 2nd parameter because the return type is specified in the 1st position again. But if we try to omit the template arguments altogether, we're going to get a compiler error because the return type can't be deduced by the compiler. Even if we put in an empty pair of angle brackets, we're going to still get a compiler error because the compiler can't deduce the return type. And this is really all I wanted you to see in this lecture. Hopefully you know that you can specify multiple template parameters for your functions. You know that there are some problems if you try to specify the return type as one of the other parameters you are using for the input of your function. We saw that a way around this is to specify a separate template parameter for the return type, and we have seen that you have much more flexibility when you specify the template parameter for the return type first here. That's going to give you the flexibility into how you call your function. You're going to have much more options. For example, we can specify all the 3 template arguments. This is going to work. We can only specify 2. This is going to work. We can only specify 1. This is going to work. But the moment you go and specify less than 1 template argument, you're going to get a compiler error because the compiler can't deduce the return type. This is really all I set out to show you in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to learn about template return type deduction with auto. And we're going to see a better way we can do what we're doing here by specifying a separate template parameter for the return type. Go ahead and finish up here and meet me in the next lecture.